Welcome protein coders. Let's build some coding muscles. Today we're gonna see Bellman-Ford's algorithm. It's a single source shortest path algorithm. Okay. So why we need Bellman-Ford's? Because Dijkstra fails when there are negative edges in the graph. Let's see with the example in the first graph. Let's start from the node 0. So it will be a distance 0. Now we will mark 0 as explode and move to node number 1, which is a distance 3, and replace the distance of 1 as 3. Now we will pop out 1, mark it as explode, and then because there is no node, so we'll leave it. Then we will get 2, and from 2 you can see we have a better shorter distance to 1, which is -2, right? But we can't update it because 3 is already explode, so Dijkstra is not working. Let's see in the graph 2, we have a cycle. Okay, so again let's start from 0. If we go around the cycle and come back to 0, you can see we will have -1 as shortest distance. So that means we have reached 0 via some path at -1 distance, which is not possible, right? So whenever we have negative cycles present in our graph, we can't have shortest paths. Okay, now let's see in the third case. We have a cycle, but if we go from 0 and come back to 0, it will be some positive value 1. Okay, so we can have shortest path here. We'll see how we're going to do it using Bellman-Ford's. So we have 3 observations here. Dijkstra fails with negative edges, can't have shortest path when have negative cycles present. And one more thing, Bellman-Ford is only for directed graphs. Why I'm saying this? Suppose we have an undirected graph of 2 edges with a negative weight. Okay, so if you see carefully, it is nothing but a cycle, right? A cycle with a negative weight, so it will be a negative cycle. So we can't have the shortest path here. Now let's discuss how Bellman-Ford works. First thing is graph should be directed with no negative cycles. Second point should be relax all edges. Okay, v minus 1 times, and v is number of nodes. This is the step 1 of Bellman-Ford, and the second step is relax all edges one more time. This is to detect negative cycles, and that's all, guys. This is all Bellman-Ford, these 2 steps. Okay, in Bellman-Ford it says after v minus 1 times we should have get all the shortest distance possible from the source node. Okay, there is one note I have to make. If graph is undirected with positive weights, we will not use Bellman-Ford. Okay, we have a better algorithm which we studied, Dijkstra. And why is it? Because if you see here in Bellman-Ford, what we are doing, we're relaxing all the edges with v minus 1 times, right? So v minus 1 into e, it will be v into e times. But Dijkstra is v log e, so which is better than the v times e, right? So that's why we'll use Dijkstra at that time. Now let's see the code for the Bellman-Fords. These 2 steps only, guys. We will write these 2 steps only. Let's see in the code. We first create the distance vector, right? Initialize every element with infinity, and then distance of source node should be 0. Now let's start the for loop till v minus 1. Okay, what we'll do, we will relax the edges. Simple. Let's get the u, v, and the edge weight. Now let's relax them. So if distance of v is greater than the distance of u plus weight, then we will simply assign it, right? Distance of v equals to distance of u plus weight, and that's it, guys. We'll close the loop. Now we will repeat the inner loop for one more time to detect cycle, right? So let's copy this. Okay, and if we have one more time a condition to relax the edge, we will just return -1, or at the last we will return the distance vector. Now let's revise what we have studied. We saw Dijkstra fails with negative edges. We can't have cycles. We can't have shortest paths when have negative cycles present, right? And the Bellman-Ford is only possible in directed graphs. Okay. Now we saw what we are doing in Bellman-Ford, relaxing all edges v minus 1 times, and then doing it one more time to detect negative cycle, right? At the end we are returning distance vector. Now I want to discuss one more thing with you guys. Let's say we have a graph, so we can have undirected and directed graphs. Undirected graphs, we can have negative and positive edges in both of them. Okay, so if a graph is undirected and having negative edge, then it also can have negative cycle or positive cycle. Similarly in directed graph, negative cycle or positive cycle, right? But when we have positive edges in undirected graph, we will use Dijkstra because of better time complexity. And we have directed graph and we have positive edges, then we already studied this question. We can use a process of topo sort, right? We will get the topo sort and then process the nodes, right? Now in the case of negative edges, in the undirected graph, if we have negative cycles, in both the cases, we can't find the shortest path algorithm. We see this, right? We saw this. We are moving into a loop. But when we have positive cycles, we can use Bellman-Ford, right? But there is a catch here. I did a mistake deliberately so that you don't get confused. Imagine if we have an undirected graph, even with positive cycle, if it has a negative edge, then also we can't use Bellman-Ford, right? Why? Because suppose, let's say we have two nodes, okay? It's still not possible. So if we have two nodes, let's say, right? And we have a negative weight in between them, then it's a negative cycle edge here, right? When we get to this point, we will again go into the loop. So it's not possible. Okay. But in directed graph, if we have negative cycle, we can do one more thing, right? We can use the Bellman-Ford to detect the cycle, that we have a negative cycle or not in our graph, right? We can use the Bellman-Ford for detecting negative cycle. But if you see, if the graph is undirected and it has a negative edge, we can completely say like we don't need to check for negative cycle and positive cycle. It doesn't matter. You can wholly say the shortest path is not possible. Okay. So can't have shortest paths. So that's all from my side, guys. Thank you for listening. If you have any questions, please mention them into the comment box. You will find the problem and solution link into the description box. Okay. If you don't understand, don't like, don't subscribe. But if you do, please show some support. Keep practicing, keep smiling. Thank you.